315 meters long, 33 meters wide, the ocean liner SS France, which for a long time was the largest of its type in the world, could cross the Atlantic in only 5 days. For the port of Saint-Nazaire in 1957, this was an outstanding shipbuilding project. More than 3,000 people worked on assembling the liner.
The amount of different basic tasks that had to be coordinated was really quite remarkable.
The many innovations incorporated into the SS France proved to be a turning point in shipbuilding.
A huge amount of the metal parts, the steel hull plating in particular, came in prefabricated panels.
The engineers had to develop new technological solutions in order to meet the high-level requirements.
It was the boilers which really pushed things forward on a technological level. Whereas the Normandy had 27 boilers, the SS France only had 8.
Between 1962 and 1974, the SS France carried out 377 transatlantic crossings and transported more than 770,000 passengers. The liner has been etched into the collective French memory for decades.
It was the largest, most powerful, and fastest ship in the world.
The SS France was a magnificent piece of work.
And now the legendary vessel has been reborn. 195 meters long, 26 meters wide, with a capacity for 460 passengers, the new SS France will sail sometime between now and 2022. It's a challenge taken up by this man, Didier Spade, whose dream is to have a new flag bearer for France.
There's a continuity between the new SS France and the old one, when it was a cruise liner.
This new era cruise liner is marked by its original and daring design.
What's fascinating about this ship is that it sets new standards for shipbuilding.
But in terms of innovation, the biggest challenge is undoubtedly the environmental one.
We're looking into ways of enabling the new SS France to be the most ecological boat possible.
The ship will have all of today's cutting-edge technologies, and what's more, they'll be able to be upgraded.
The SS France, 2 eras, 2 ships, but a single unifying concept: excellence. Join us on an exceptional journey into the past, present, and future of a legendary vessel, the SS France. The idea for the SS France was conceived just after the war in 1946. France had endured 6 years of conflict. The fleet of ocean liners of the CGT, French line, had suffered serious damage, notably the Normandy, which had been lost to fire in the port of New York on the 9th of February 1942. The French line's prestige clearly rested on the Le Havre-New York route, which saw 900,000 passengers a year take the journey. But by the end of the war, the fleet was aging and inadequate. The company felt obliged to recapture its past glory in the face of foreign competition.
We were no longer alone. At the time, there were the English, the Americans, there was also the Dutch, the Swedish, the Italians. In fact, everyone seemed to have ocean liners.
But the CGT had no money to invest in the project. It had to fall back on state aid. Whereas the former just wanted to have a big ship to help regain its Atlantic supremacy, the latter was concerned with profitability. 4 long years of negotiations ensued.
There were 2 strongly held points of view. Some wanted to build a single large ocean liner, like the Normandy. Others called for 2 smaller, more versatile liners.
There would have been very little difference in cost between 1 big liner or 2 small ones. Crew numbers would have been identical as well.
Everyone was worried about the liner, and talking went on for years. In the end, it was a political decision.
On July 25, 1956, the final decision was made official. French President René Coty announced the construction of a single, large ocean liner called the SS France.
Just like that, the order was announced, and everyone rejoiced. It was to be a legendary boat, and so it was an extraordinary opportunity for the shipyard. That much was clear.
The 315-meter-long vessel was designed to be not only the world's longest ocean liner, but the fastest. It would be able to reach New York in 5 days, traveling at a speed of up to 31 knots. It took 4 years and more than 3,000 shipbuilders to construct the Colossus. 260 kilometers of steel and copper pipes and more than 27,000 tons of sheet metal were used to assemble it. The ship's launch date was chosen according to the tides. It took place on May 11, 1960 at 4:15 in the afternoon, 30 minutes before high tide.
It was extremely moving. We were just 10 meters away from this vast wall of metal. We were surrounded by huge crowds, just waiting for the moment for the ship to set sail.
This already delicate operation was made more risky by the sheer weight of the ship. A bulk of 33,500 tons and 315 meters had to slide down the slipway. The Normandy, which up to then had been the largest liner built in France, had only weighed 28,000 tons, so this was a first.
Everyone was holding their breath. And when it started to move, the suspense was over.
TV and radio stations from around the world broadcast the launch. It was an international event. And it was only after the liner was safely in the water that General de Gaulle delivered his famous speech about France espousing the sea.
Et maintenant que France s'achève et qu'il s'en aille vers l'océan pour voguer et pour servir. Vive la France!
Although the hull and the decks had been finished, both the superstructure and the interior fittings still needed 18 months more work. On February 3, 1962, the Sea Giant left Le Havre for its first Atlantic crossing. With a horsepower of 160,000, the bow could cut through the sea at a speed of 31 knots. 1,958 passengers were on board, some of whom had reserved their tickets as far back as 1956. 5 days later, the SS France sailed up the Hudson River and docked triumphantly in New York.
The SS France was lauded by both the American and international press, especially as this latest product made in France was of high quality and targeted for an American clientele.
The challenge of making a ship which would combine speed and comfort had been met. The legend of the SS France had been born. The engineers had pulled out all the stops in 1957 to get the construction of the SS France right. Even though the Saint-Nazaire shipyards were used to building big, this particular test required precise and pinpoint organization. Jean-Noël Dacremont, Serge Millet, and Guy Salnave all worked on the Atlantic shipyards. This is their story.
This ship was intended to beat all existing records, and for the shipyards, we were really up for the challenge. But it wasn't easy. It was a real test to get 3,000 people working together on a common objective. The amount of different basic tasks that had to be coordinated was really quite remarkable.
Every worker and every engineer involved in the construction all felt like we were taking part in an historical project, which would be a turning point in the world of shipbuilding.
In 1962, the ship's style, in particular its two huge red funnels, caught people's imagination, and some of its technological innovations were unprecedented. The SS France had to meet 3 criteria. It had to be comfortable, fast, and above all, economical. But to meet this last requirement, it had to be light. And the constructors met this challenge by using new materials. The superstructure, all the areas situated above the hull, such as the promenade decks, were built out of light aluminum alloys and not out of steel.
This brought down the weight of the ship considerably. In comparison, the SS France weighed an impressive 13,000 tons less than the Normandy, which was built entirely out of steel.
Metal is always required in shipbuilding, be it steel or aluminum, and nothing much has changed at this level. The mechanical properties of steel are incredible. We're able to make ships 300 meters long with a thickness of steel ranging between only 6 to 20 millimeters. We're almost talking cigarette paper.
As for the hull, the engineers tried out another new technique. Instead of riveting the different metal parts together, as on other ocean liners up to that point, these ones were entirely soldered.
It was an extremely modern ship at the time, in that it didn't use classic materials such as steel and aluminum. The hull was soldered, which is still the practice today. At the time, it was more or less a first. There had been more than 10 million rivets used on the Normandy. In some ways, the SS France represented the beginning of modern shipbuilding.
This meant a benefit in terms of weight, and what's more, it improved the thrust through the water.
At the last moment, however, safety protections were added with strips of metal riveted together. They were generally worried that the welding wouldn't hold. The Liberty ships, the mass-produced ships that were built during the Second World War, had welded sections. It transpired that when these ships were used again after the end of the war, they split in two. This traumatized engineers. And so, for the SS France, they decided that some of the lower parts of the hull would be reinforced by large strips, which would be riveted together in case the welding gave out. But there were absolutely no other rivets elsewhere on the hull.
The construction of the SS France gave the shipyards an opportunity to test new processes. Instead of welding countless metal plates together to make the hull, a new technique was introduced.
A huge amount of the metal parts, the steel hull plating in particular, came in prefabricated panels.
Each panel weighed between 30 and 80 tons, and they had to be fitted to the last millimeter. It was a rigorous and meticulous job, made even harder by several complications.
We were restricted by the limited power of the cranes. We only had 4 of them, and we had to combine them. We couldn't lift more than 120 tons.
Another factor made things more difficult for the shipbuilders: the slope of the slipway on which the hull was being built. This 310-meter-long ramp had a gradient of 5.5%.
We weren't working with straight lines anymore.
It made putting the panels in place a bit more difficult because they couldn't be dropped in horizontally. They had to be fitted in at an angle.
To correct the vertical and horizontal lines, the shipbuilders needed 4 cranes to provide the right angles for the panels. Added to the problem of the slope, there was another constraint which hadn't been foreseen. In order to assemble the different parts, the shipbuilders had to take into account the expansion coefficient due to the exposure of the ship to the sun. During the day, the liner gained several centimeters in length and then lost them again during the night. To get round this expansion problem, some parts, such as the propeller shafts, which had to be perfectly aligned, were fitted at night. The keel also had to be well thought out. 19 different scale models were created and tested for their hydrodynamic properties. The seaworthiness was tested in an artificial wave tank, which recreated the worst types of Atlantic storms. The hull was fitted with a bulbous bow, with a bulge at the front, improving thrust through the water and increasing fuel efficiency. When the ship is operating, the bulbous bow creates a wave at the front. At a certain speed, the trough of this additional wave coincides with the crest of the bow wave, and they cancel each other out. Drag is therefore reduced, and ships can go faster at the same power.
These were transatlantic ships. The aim was to get to the U.S. from Europe as quickly as possible.
The SS France was supposed to reach New York in only 5 days after leaving Le Havre. There were 4 propellers, 2 on the port side and 2 starboard ones, all connected to a transmission shaft driven by steam turbines. There were 8 boilers fueling the turbines, which in turn drove the propeller shafts. These shafts were between 100 to 150 meters long, 70 centimeters in diameter, and each weighed 53 tons. They could turn at up to 162 revs a minute. Fitted at the end of the shafts, the 4 propellers were 5 meters 81 in diameter and weighing 27 tons apiece. To drive these enormous shafts, the turbines had special blades which transformed the steam pressure from the boilers into rotational movement. The huge reduction gear was a vital cog in the machine, allowing 4 engines of 40,000 horsepower each to run day and night. The motorization of the SS France is one of the more innovative features. The 8 groundbreaking boilers, which fueled the 4 turbines, were capable of producing steam at 500 degrees. Their energy efficiency was far superior to that of any previous ship. Only 8 boilers were required to reach 160,000 horsepower, as opposed to 29 boilers on the Normandy. This helped bring about a saving in fuel, estimated between 40 and 50%.
It was the boilers which really pushed things forward on a technological level.
The SS France burnt only half as much fuel as the Normandy.
Fuel consumption was vital, for even if the overall structure was lighter and the form of the keel improved, the SS France still managed to burn 1 ton of fuel per nautical mile.
At a speed of 30 knots, that makes 1 ton every 2 minutes. Think about it. 3,600 tons of fuel were needed for the Le Havre-New York crossing, and the same amount for the return journey.
Boilers were traditionally fitted into liners only after the ship had been launched. But for the SS France, the engineers decided to put the boilers in during the construction of the hull itself.
It was a revolutionary idea. It saved time and improved efficiency. However, the weight had to be calculated, because there was a limit to how much the hull could weigh. The hull would have to slide down the slipway at a certain angle, and it could become dangerous.
There were no forward propellers, but in separating the port and starboard propellers, the ship was able to turn 90 degrees and even make a complete 360-degree turn.
The water that the propeller throws up bounces off the rudder. If the rudders are turned 45 degrees, then the water will be pushed onto the sides. So there's one propeller driving forward with a locked rudder on one side and another propeller in reverse. The forces involved allows the ship to turn round on its axis.
At the time the SS France was being built, the shipyard had its own separate workshops for joiners, boiler makers, mechanics, plumbers. As well, the shipyard carried out almost all types of trades. It's not the case anymore.
Nowadays, large cruise ships are just huge jigsaw puzzles, really. Each element is subcontracted and built in a number of different countries. There's all the equipment, especially the huge equipment. Once the propeller engines are on board, they can be accessed on 3 different levels. The liners are like tower blocks. Even though all the equipment can be built in France, it's mostly built nowadays in other European countries, and often sometimes in Asia. And so logistics plays a huge part, both in terms of timing and organization, so that all the elements can be assembled and brought at the right time to the construction site.
Building the SS France involved both revolutionary techniques, such as prefabrication, as well as the know-how of thousands of men and women. More than 27,000 tons of steel and other lightweight metal plating were fitted with pinpoint precision. It took 17 minutes, 10 men, and 4 cranes to place the final piece, weighing 31 tons, on the ship's prow. The hull was then joined up to the promenade deck at a height of 30 meters. Installing the radar mast was one of the most delicate and spectacular operations in this remarkable construction period. The mast was made out of a light alloy. It was 30 meters tall and weighed 6 tons. This precision job required hours of concentration and coordination. The hull was complete. The decks and the lighter alloy fixtures were welded. The mast was in place, but the 2 gigantic funnels still had to be assembled. Made out of a light aluminum alloy, they each weighed 40 tons, of which 19 tons for the wings and 2 tons for the caps.
They were built inside the Penwet Quay workshop and transported on a trailer. That was really something to see.
To complete the construction of the funnels, special wings with a span of 19 meters were fitted. The funnels were 15.6 meters high, the equivalent of a 5-story building. Their unmistakable shape contributed to the popularity of the ocean liner. The funnels had been tested meticulously in wind tunnels, and there was a specific reason for their shape. The engineers had to work out how to deal with the fumes and the soot interfering with passenger comfort, a common problem on liners.
Whenever passengers were on the upper decks, and depending on the wind, there would be deposits of soot on the benches and deck chairs.
The funnels were quite something. They'd been tested out in wind tunnels.
So the shipyard engineers came up with the idea of directing the fumes away according to the wind direction via a system of wings.
These wings, which made the ship so distinctive, enabled the fumes and the soot to be caught by the wind on either side and carried away from the passenger decks.
If the wind came from the starboard side, the fumes would be carried away on the same side. The wind would hit the hull, rise, and drive the fumes upwards, where they would be caught in the slipstream and then carried out to sea.
The liner's design was impressive, especially with the 2 winged funnels. They really caught the eye.
If you saw the funnels in the distance, you knew that the SS France was coming.
Concern for passenger comfort inspired the engineers to create the most surprising innovation on the SS France. 4 stabilizer fins, 2 on each side, helped to reduce rolling.
The vibration problems of the Normandy had been well documented. When the ship was going at 30 knots, it wasn't a good idea to be at the back of the boat because the hull's vibrations were significant and passengers suffered enormously. So the SS France engineers came up with the idea of extendable stabilizer fins. In rough conditions, the fins would protract from the hull and provide more stability, and therefore greater passenger comfort. It was a major innovation.
These fins had a surface area of 9 square meters. They were shaped like side rudders and turned according to the ship's movements in order to improve stability. The innovation helped to cancel out seasickness.
Rolling was detected in advance by gyro compasses, which then triggered the stabilizer system. The fins would be turned in one direction or another according to where the rolling was coming from. The port and starboard fins would operate inversely, so that the rolling would be counterbalanced and neutralized. Rolling of 10 to 15 degrees could be reduced to 2 degrees, for example.
But even the best stabilizing system could not combat a raging sea. Jean-Yves Bonis recalls one particular incident.
We were in the middle of a major Atlantic depression, which was fairly typical. The sea was hitting the rear port side. So the port stabilizer fin was deployed, but only one of them. Usually they worked in pairs. When we were in the trough of the waves, this caused the port propeller to start to come out of the water. We were going hard to port at this point, which meant that the ship started to bear away at almost 40 to 50 degrees, perhaps even more than that, 70 degrees, before we could stabilize. It only lasted about 10 minutes, and we were able to get back up to 30 knots fairly quickly.
The colossal liner had to be ready for service for November 1961. The shipbuilders worked around the clock to meet the deadline.
We weren't really sure how we were going to get it ready. It was such a gigantic undertaking.
Workers, foremen, and engineers all worked relentlessly in order to meet the challenge. On November 19, 1961, at 2 p.m., 1,552 days after the first piece had been fitted, the SS France left Saint-Nazaire for good and made its way to Le Havre, its home port. The SS France was a giant of a ship. 315.66 meters long, 33.7 meters wide, weighing 57,607 tons with a gross tonnage of 66,348. In other words, a volume equivalent to more than 187,000 cubic meters. It could take 2,032 passengers on board, as well as a crew of 1,100. At the time, it was the longest and most powerful ocean-going liner. With a horsepower of 160,000, the SS France could reach speeds of 35 knots and cross the Atlantic in only 5 days. Keeping to a timetable was absolutely vital, not only because of punctuality, but for other important reasons too. In order to be able to dock in New York, the SS France had to run up alongside the 360 meters of Pier 88. The currents there were quite strong, and with the boat measuring 315 meters long, the risk of drifting and crashing into the pier were high. Jean-Yves Bonis was a captain on the SS France. He was well aware of all the different constraints attached to such a big ship.
To be able to dock along the 360 meters of the pier, we had to come in during slack water. It was a very delicate operation.
The SS France had to wait for the stand of the tide when there is no movement in the tidal stream. But this period only lasts 20 minutes.
It was so tricky that someone on the pier had to throw small bits of paper into the sea to check if the water was indeed slack. And then they would radio in to tell us if it was okay to dock.
There was another problem encountered. In both Southampton and Le Havre, the shipping channel was not deep enough for the ship's 10.5-meter draft.
We had to arrive during high tide. Otherwise, the water in the harbor wouldn't be deep enough for the ship. So, whereas in New York we were restricted by the current, in Le Havre and Southampton it was the depth of water which was the issue.
In the 1960s, the SS France was the ocean liner par excellence. It was the biggest, the fastest, and the most beautiful. Its distinctive pair of red and black funnels helped to make it an outstanding ambassador for France.
The SS France symbolized the lifestyle of the 1960s. More relaxed and so much more modern.
It goes without saying that the SS France was an exceptional ship on all levels.
SS France was the realm of aluminum. Top artists of the day contributed to its very modern interior decorations. The ship was without a doubt a high point of French-style luxury on show.
More than 50% of transatlantic liners had been damaged because of fires. Anything made in wood was prohibited by new regulations in Europe. So the SS France took this to the extreme by using metal everywhere, including the furniture. It made the ship uniquely modern.
Some of the rooms were really large, such as the first-class dining room. It was huge, 9.5 meters high, which is almost the same height as the Hall of Mirrors in the Château de Versailles. It was impressive. But there were no portholes, so that passengers wouldn't feel queasy during their meals by seeing the horizon rise and fall. It might have interfered with their digestion.
Each cabin had air conditioning, which was a crowning luxury for ocean liners at the time.
The whole ship was air-conditioned. There were several central cooling plants on board. A single system would not have been enough, so there was one per section.
There was a concert hall with 664 seats, designed by architect Georges Peynet. He skillfully managed to create a dedicated space in the center of the ship of 3,000 cubic meters.
It's the type of space where you can't have pillars or structures which would block the view of the stage. So you have to have big open spaces, and structurally, this adds constraints and complicates matters. The supporting structures have to be diverted around the space, while at the same time preventing anything from collapsing or vibrating.
Since the emblem of French art de vivre was its cuisine, the SS France in 1962 was specially renowned for its food.
First-class passengers in particular hadn't chosen the SS France by mistake. They wouldn't travel on the United States or the Queen Elizabeth for the food. The SS France was undoubtedly the ship where one ate the best. It offered one of the best dining experiences in the world.
Everything on the SS France was taken to excess. For every crossing, there were 130 tons of food supplies, between 7,000 and 8,000 meals prepared each day, a wine cellar of 75,000 bottles, and more than 422,000 items of bedding, towels, and kitchen cloths. Between 1962 and 1974, the SS France carried out 377 Atlantic crossings, 93 cruises, including 2 round-the-world tours, and transported more than 770,000 passengers, many of whom were celebrities. But perhaps the most famous of these was the Mona Lisa. In January 1963, this unusual passenger, which was to be exhibited in New York, was given a special police escort. An isothermal box protected the painting from vibrations or changes in temperature. At the time, the painting was valued at an estimated 500 million francs, or 40 million more than the cost of the ship itself. The SS France crossed the world's oceans for 13 years. Its elegant outline was a symbol of modernity and national pride. But competition with air travel was fierce, and the ship's running costs soon became too high.
It made around 100 cruises and 2 round the world, which showed that there was a clear trend towards this sort of luxury cruising. But by the beginning of the 1970s, the market began to change, and the French hadn't really anticipated this.
Despite the range of technological innovations and the unique high-quality luxury offered on board, the SS France was decommissioned at the end of 1974.
The SS France was a national treasure. Pride and prestige seemed to be more important than changing with the consumerist times.
The SS France was sold to a Norwegian ship owner in 1979 and renamed the SS Norway. It was transformed into a cruise ship.
Of the 8 boilers, only 4 were put into service. Only 2 of the propeller shafts were operated. That meant that it would simply be a cruise ship. 2 decks were added, there were a few more cabins, and the newly named SS Norway would go on to be profitable.
In 2006, the liner, now under the name of the Blue Lady, docked at the Alang scrapyard in India to be dismantled. This finally took place at the end of 2009. 60 years later, the legend has been reborn. A new SS France is set to sail again sometime before 2022. Although bearing no comparison in terms of the size and scale of its predecessor, it shares the same approach to cutting-edge technology and high-end luxury, and aims to be a flag-bearer of French excellence once again. Today, the cruise industry is a huge market and has opened up considerably. Every year, more than 25 million passengers around the world go on cruises. This figure is expected to rise to 35 million in 10 years' time. Based on these facts, Didier Spade decided in 2009 to create a cruise ship concept that would be new to the market.
In 1962, the SS France was conceived as an avant-garde ship with all the latest technology on board. What's behind the new SS France is the idea of perpetuating its singularity by having something unlike any other ship.
But how to combine continuity with the past and innovation? The work of Didier Spade and his team consisted in finding a clear identity for the new SS France.
When we started designing the ship, our first job was to look at the old ship and work out what was emblematic about it, the symbolic elements that we could also use. The funnels immediately stood out. They really distinguished the SS France from all the other ocean liners at the time.
The 2 large superstructures of the new SS France reference the funnels of its predecessor, but have been reworked as living areas and passenger cabins. Although managing the fumes is no longer an issue, the engineers still have to deal with other technical constraints, especially in terms of stability and weight distribution.
Basically, a ship is just a supporting structure onto which elements are loaded. In this case, it's heavily loaded at 2 particular points, and less so at other points. So this type of ship has specific technical constraints, which demand a particular structural design.
The new SS France has its own afterdeck, just like its predecessor, but it takes the idea even further by lowering it closer to the sea. Various technical factors had to be taken into consideration.
We had to take bad weather into account and work out what would happen if waves reached the afterdeck.
Special structural studies were carried out and technical solutions were found to get the best out of the platform.
The good thing is that if a ship is open at the back, the water enters easily, but it also leaves just as easily. So, if it's been well designed, there aren't any real dangers.
There are special materials which have a glass window effect, but in fact have metal lining inside them. So they're able to resist any waves that might hit the rear of the ship. Sloping decks were created to enable the rapid evacuation of water. And of course, watertight doorways were installed. All of these things were an integral part of the ship's design.
Having a marina right down by the water also means being in proximity to the propellers, the rudders, and the engine pods. Not only does everything have to be fitted into a tight space, but the propeller vibrations also have to be taken into account.
We made the bow of the ship much straighter. It has a sheltered observation lounge incorporated into it. This allows passengers to go to the sheltered foremost point of the ship.
If it's to become the new flag bearer for France, it'll be down to its size. It will have to stand apart from other cruise liners, which have become floating cities, capable of transporting 5,000, even 7,000 passengers.
It will not try to outdo existing ships in terms of size. It'll be on a much more human scale.
It's a ship that'll be able to navigate areas that other large liners cannot navigate, and that will give it a considerable advantage in terms of what it can offer to passengers.
Profitability is always a key issue. All sorts of variations were tried out in order to optimize passenger capacity.
Plenty of things were added, taken away or modified. One deck here, one less there. The funnels were moved. The palm garden was made bigger, then smaller again. We tried all types of layouts.
No sooner had the style of the new ship been found when another step in the project's development came along.
Originally, we wanted to keep the ship on a human scale with a capacity of around 600 passengers. Then, after consulting a number of specialists in the cruise industry, particularly those in the US, where the business model was for having bigger and bigger ships, we decided to increase our capacity to nearly 800 passengers. And so, of course, that meant increasing the size of the ship.
The ship's income would thus improve considerably, but the race to make profits has a downside. With this new layout, the gross tonnage of the SS France would rise to 70,000, which is equivalent to 198,000 cubic meters. It would now be 260 meters long and 32 meters wide. However, since 2014, there's been a huge rise in the construction of cruise liners, and the order books of the three main shipyards which have the necessary expertise to build these kinds of boats, Saint-Nazaire, Fincantieri in Italy, and Meyerwerft in Germany, have been filling up significantly. Liners are being built with capacities for several thousand passengers, with costs topping €1 billion. This is boom time for the sector, which had been in serious difficulty up to then, but it affects the production schedule for the new SS France.
The bigger the ship, the harder it is to find places where it can be built. So once we realized that there was an overload of orders, we decided that the best thing would be to reduce the size of the ship. This would mean that we could envisage partial subcontracting, something that is easier to do with smaller ships than bigger ones.
This was the solution chosen in 2016. The ship's dimensions were reduced. But in order to keep exactly the same design, the reductions had to be homothetic. That's to say proportional across all features. But reducing the size of a ship proportionally has other consequences.
Reducing the size of the ship was a real headache because we had to keep its distinctive design features. So the whole of the ship had to be rethought while not losing its distinctive appearance.
Along came another problem. The cabins had a minimum surface area of 30 square meters, and there was no intention to reduce their size. Instead, it was the number of cabins that was reduced, and consequently the passenger capacity. Here are the two versions. Version 1 is 260 meters long and can hold 800 passengers, and version 2.0 is only 195 meters long and holds 460 passengers.
So you can see that, despite a considerable reduction in the size of the ship, its appearance has not changed at all. This was something that we found quite difficult to do, because the whole ship had to be rethought.
One of the thornier issues that had to be dealt with was the ship's propulsion. The propeller shafts were replaced by a powerful and also incredibly flexible system, podded propulsion. The pods are electric motors on which one or two propellers are mounted and housed inside the ship's hull. They can pivot through 360 degrees, allowing maximum maneuverability.
Nowadays, they've been perfectly tested. They're reliable, they're cheap, and they work really well. Many of the problems of vibration, which often occurred in ships equipped with more conventional propeller shafts, have been eliminated.
The new SS France will be equipped with 3 independent propulsion systems for safety reasons.
The regulations stipulate that any ship operating with passengers on board must have 2 totally independent means of propulsion. If there are 3 systems, then this means if ever one of them breaks down, there will still be 2 which will work, and therefore there will be no interruption in the cruise program. So it's a safety issue.
Modern ships' power bears no comparison with that of the SS France in 1962. Cost and ecological considerations are now the key factors in having the right type of propulsion.
Nowadays, no one can afford to fit ships with as much power as in the past, as both the price and consumption of fuel is so costly. It just wouldn't make any sense.
So to make it as green as possible, it was decided to reduce its speed.
It was the first step, and a spectacular one too. When you go from a cruising speed of 20 knots to one of 12 or 13 knots, you cut the fuel consumption in half, perhaps even by 2/3. So that was where a lot of research took place. Then obviously we looked into what sort of cleaner energy we could use.
The choice of fuel is a key consideration, for not only does the ship have to sign up to a policy of sustainable development, but other factors have to be taken into account before it can operate.
Everything is highly regulated, and there's a real revolution going on at the moment. It's fascinating because there are virtually no ships being built today on the old model of using heavy fuel oil. So people are turning to more refined oils, such as diesel, which has to be in use for a while, but especially gas, in other words, LNG.
LNG, liquefied natural gas, is a gas that has been cooled to minus 160 degrees and condensed to a liquid form. It's made up chiefly of methane and produces considerably fewer microparticles than traditional fossil fuels. It also has the advantage of taking up much less storage room. Transforming it into liquid brings about a reduction in volume of 600.
In terms of transport, 1 cubic meter of LNG is equivalent to 600 cubic meters of gas. So clearly, the storage capacity on a ship will be significantly improved and compressed.
However, the one major disadvantage with LNG is that since it's a relatively new process, refueling cannot take place everywhere.
At this moment in time, it's rather tricky to operate a ship with only LNG as fuel. In fact, in certain parts of the world, it would be almost impossible.
To get around this problem and enable more flexibility when in operation, most engines are able to call upon 2 different fuel sources. This is the option that Didier Spade and his team are likely to choose for the new SS France. Furthermore, the shipbuilders are looking into a new technique, which reduces the ship's effect on pollution when in port: shoreside electrical power. This is a shore-to-ship power supply, enabling the liner to turn off engines and power generations and thus save fuel.
Shore power is one of the most innovative and most important solutions going forward because it helps to solve the problem of pollution caused by CO2 particles from the engine fuel. When the ship is at berth, the engines are shut down and power is provided from the local electricity network. It's not a straightforward technology. It's quite onerous because the power needed on a ship is vast and not comparable to the needs of a house, for example. It's more like the power needed for a whole neighborhood. There's a safety aspect, and qualified personnel are needed. A whole set of procedures need to be gone through to ensure there are no accidents, and just as importantly, that there are no breaks in power. When you have 5,000 people on a cruise liner and 500 of them are taking their shower, having a 5-minute cut in electricity is not an option.
The other important problem linked to passenger comfort, just like with its predecessor, is stability. And the new SS France will be equipped with fins capable of reducing roll by 90%.
In this respect, there haven't been any major innovations, at least not for this type of ship.
There are often 2 pairs of stabilizer fins, and for the bigger ocean liners, such as the Queen Mary II, there were 4 stabilizer fins. Basically, it's to do with the level of comfort required, but it's also linked to the speed of the ship.
There are other stabilizing systems, but they're not suitable for cruise liners. Much smaller boats, such as yachts, are equipped with gyroscopic systems. They consist of a flywheel which rotates rapidly inside the hull to keep the boat from rolling. On aircraft carriers, such as the Charles de Gaulle, there's a system of movable masses which move underneath the decks. The new SS France should be ocean-bound by the year 2022. It will be a stylish and innovative ship for 460 passengers, 195 meters long and 26 meters wide, setting it apart from all other cruise ships. The SS France of 1962 was an exceptional cruise liner whose innovations were a turning point in terms of appearance and modernity. It took the shipbuilding industry into a new era. A great many of its technological innovations, such as prefabricated elements and the stabilizing fins, were groundbreaking and are still widely used today. This unique liner has been a huge inspiration for designers of cruise ships over the decades. Today, the new SS France, which has taken up the mantle of the avant-garde, aims to be the new flag bearer for the French on the world's seas and bring the legend back to life.